Hi everybody, these are our answers to our practice test for our midterm in matter. And our first question is Johnny and Marie are arguing over the lab results from their balance. Johnny says that the balance reads exactly 1.44 grams. Marie says it reads exactly 1.46 grams. Who is right? Well, this goes with the activity where we all had the same exact block, but we traded balances. And all of you found that not every balance gave you the exact same mass for the exact same block. And we determined that the mass of the block really wasn't changing. What was really changing was the balances measurements, because balances aren't perfectly accurate. They all have degrees of error. So we never ever have an exact number. So there's a couple of answers you could have on this. First one, you could say they both could be right. The difference in their numbers is very small, and that difference is so small it could just be due to scale error. You could also argue that both of them are wrong because both of them use this word exactly. And scales are never exact. Every form of measurement has an error in it. And scientists need to be honest about what that error is. And all of you will need to be cognizant of that as you use the balances the rest of the year. You're going to have to think, what is generally the number, never what is exactly the number. The next one. If we can't see something like air, how do we know it's there? Well, we had a couple different ways we found air was something in class, but the biggest one was when we put it on a balance and found out that it made the balance go up by over a gram, which is significant. So if something has mass, it's something. Mass is the determiner if you are something. Johnny was playing with Legos pretending they were the smallest pieces of chemical matter. He said he would put some of the Legos together to form an atom. What would you say to Johnny? Well, the smallest piece of chemical matter is an atom. So you're not going to put Legos together to make an atom. When atoms go together, they make molecules. So again, the smallest chemical piece of matter is the atom. When they go together, you get molecules. Molecules are groups of atoms. Next, if you added a proton to a nitrogen atom, would it still be a nitrogen atom? And here we need our periodic table. We've talked about every one of these has a number by it. 5, 6, 7, 8, 1, so on. That's the atomic number, and that number tells you how many protons it's got. Hydrogen is 1, not because we found it first, but because it's got 1 proton. Helium is 2, not because we found it second, because it's got 2 protons. Helium's 3, beryllium's 4. Now we learned some other parts, which are neutrons and electrons. You can change the number of neutrons and electrons in an atom and still have it be the same kind of atom. You get an ion or an isotope, and it's just a variation of the same kind of atom. But if you change the protons, you change the kind of atom it is. So it says, move it up where everybody can see it. No, the number of protons defines the kind of atom it is. If we added a proton, it would become oxygen. It's kind of scribbled in the corner there. Sorry, I ran out of space. But here's nitrogen with 7 protons. If you add a proton, 1 to 7 is 8. If you have 8 protons, you are oxygen. Again, the idea, the type of element is determined by the number of protons in its nucleus. And then finally, it says, draw a model of a lithium atom, include the protons, neutrons, and electrons. Be sure you have the right number of each. You will need your periodic table for this. Now, there's a number of things. Here is a model of a lithium atom. And there's a number of things that it's got. First of all, you have the protons with the P and the neutrons with the N inside the nucleus at the center of the atom. That's where they live. You have these electron shells or energy shells where you're showing the electrons with a little minus sign because they're negatively charged, and they live outside the nucleus. Now, the other thing we need to do is make sure we have the right numbers of these, and that is, one of those is very tricky. First of all, if we look at lithium, we just said its atomic number is 3. That means 3 protons, and you will see 3 Ps. If it is a quote-unquote normal atom, the number of electrons is always identical to that number. So 3 protons, 3 electrons, and 2 in this closest shell. The final one, which can be trickier, is the neutrons, because neutrons don't always agree with that atomic number. Sometimes they do, sometimes they don't. The key is to go to the atomic weight. And if we go to the atomic weight, we always round it. That is a weight of 6.941, so we say it's 7. And the protons make up 3 of that. So 7 take away 3 leaves 4. And so the rest of that mass, since most of the mass of an atom is made of protons and neutrons, we have 3 protons, 4 neutrons, and if you count all those up, that's equal to the atomic weight there, rounded to the nearest whole number. That is tricky, so kind of be mindful of that. But that is our lithium atom. And that's it for the first test. I hope you feel like you're ready to go.